If you enjoyed this podcast, please consider liking, sharing, and subscribing to the channel. Sharing it with your friends and family helps spread knowledge, and when we help others grow, we grow too. Thank you so much for listening. Let's dive into the podcast. The unexpected uniform signal. The year 1964 started like any other for two radio astronomers working at Bell Labs in New Jersey. Arno Penzias and Robert Wilson had no idea they were about to stumble upon one of the universe's most guarded secrets. They were trying to measure radio signals from space using a massive horn antenna. But something kept going wrong. No matter where they pointed their equipment, a strange hiss filled their receivers. The sound was faint but constant, like static that never went away. At first, they thought pigeons were the problem. The birds had built nests inside the antenna and left droppings everywhere. Penzias and Wilson cleaned the equipment thoroughly. They even caught the pigeons and moved them far away. But the mysterious signal remained. For months, they checked every wire and circuit. They tested their equipment again and again. Nothing worked. The annoying hiss was always there, coming from every direction in the sky. It made no sense. The signal had no pattern. It didn't change with the time of day or the season. It wasn't stronger in one part of the sky than another. This uniformity puzzled them completely. Radio signals from space usually came from specific sources, like stars or galaxies. This one seemed to come from everywhere at once. Meanwhile, just 30 miles away, physicist Robert Dicke was working on theories about the early universe. He believed that if the Big Bang really happened, it should have left behind a faint glow of radiation. This ancient light would have cooled over billions of years into microwave frequencies. A colleague mentioned the Bell Labs problem to Dicke's team. When Dicke heard about the uniform signal, his heart raced. He realized immediately what Penzias and Wilson had found. The two groups met and compared notes. The mysterious hiss matched perfectly with theoretical predictions. They weren't hearing equipment failure or bird droppings. They were detecting the leftover heat from the birth of the universe itself. The discovery sent shockwaves through the scientific world. Here was actual evidence that the Big Bang had occurred. But the finding raised more questions than it answered. The signal was too uniform, too smooth. If the early universe had been chaotic and violent, as many expected, the radiation should have shown hot spots and cold patches. Instead, it was almost perfectly even across the entire sky. This smoothness became the greatest puzzle in cosmology. How could something so turbulent create something so uniform? What force could have made the early universe so remarkably consistent? Penzias and Wilson had accidentally opened a window into the universe's infancy. But what they saw through that window defied all expectations and changed everything scientists thought they knew about cosmic history. Scientific dissent and alternative origins. Not everyone believed the cosmic microwave background came from the birth of the universe. When Penzias and Wilson first detected that strange radio hiss in 1965, many scientists wondered if they were looking at something much closer to home. Fred Hoyle, a brilliant British astronomer, had spent years defending his steady-state theory. He refused to accept that the universe had a beginning. The microwave background, he argued, must come from something else entirely. Perhaps it was just starlight that had traveled so far it cooled down to radio waves. Or maybe it came from dust between the galaxies, glowing with ancient heat. Other researchers suggested even stranger possibilities. Could this signal be coming from our own galaxy? Radio waves bounce around the Milky Way like echoes in a cave. Some thought the background radiation might be nothing more than local interference, amplified and scattered until it seemed to come from everywhere at once. The debates grew heated. Scientists who had devoted their careers to different theories of the universe suddenly found their life's work under attack. At conferences, arguments erupted over coffee and continued late into the night. Friendships strained. Reputations hung in the balance. Testing these alternative ideas became an obsession. If the radiation truly came from distant stars, it should vary as astronomers looked in different directions. Ancient starlight would show patterns, clustering where more stars once burned. But measurement after measurement showed the same result. The background remained stubbornly uniform. Teams of researchers built better equipment, searching for any sign that this radiation had earthly or galactic origins. They looked for daily changes as Earth rotated. They searched for seasonal variations as our planet orbited the sun. They studied the signal during solar storms and quiet periods. Nothing changed. The most persistent skeptics proposed that hot gas clouds in our galaxy were fooling the instruments. These clouds could glow with microwave radiation, creating a false signal that only seemed cosmic. Scientists spent years mapping every known gas cloud, accounting for their positions and temperatures. When they subtracted this galactic contamination from their measurements, the uniform background remained. Each failed alternative theory made the mystery deeper. If this radiation truly came from the early universe, why was it so perfectly smooth? The young cosmos should have been chaotic, with hot spots and cold regions scattered randomly across the sky. Yet the measurements showed a background so uniform it seemed almost artificial. The scientific community slowly accepted that they were indeed detecting an echo from the universe's birth. But this acceptance only made the central puzzle more disturbing. What force could have made the early universe so remarkably uniform that its afterglow still shows no significant variation today? Inflation's puzzle and unsolved anomalies. The satellites kept finding things they weren't supposed to find. As scientists studied the cosmic microwave background more closely, they expected perfect smoothness. Instead, they discovered something far more puzzling. Tiny temperature differences appeared across the sky. These weren't random spots of heat and cold. They formed patterns that seemed impossible to explain. The differences were incredibly small, less than 1 part in 100,000. Yet they were there, persistent and real. Scientists called these variations ripples. But ripples suggested something had disturbed the early universe's perfect calm. What could have created such delicate patterns in the first moments after the Big Bang? In 1981, physicist Alan Guth proposed a radical idea called cosmic inflation. He suggested that the universe had expanded faster than light itself during its first tiny fraction of a second. This super-fast growth would stretch any irregularities until they became smooth. The theory seemed to solve everything. It explained why the cosmic background looked so uniform across vast distances. It also predicted exactly the kind of tiny ripples that satellites were detecting. For years, inflation appeared to be the answer scientists had been seeking. But the more data came in, the stranger things became. The ripples weren't quite what inflation predicted. Some patterns appeared too large. Others seemed aligned in ways that defied explanation. The universe's background radiation contained features that shouldn't exist if current theories were correct. The Hubble tension emerged as another troubling mystery. Different methods of measuring the universe's expansion rate gave different answers. The cosmic microwave background suggested one speed. Direct observations of nearby stars suggested another. The difference was small, but significant enough to worry scientists. Large-scale patterns posed even deeper questions. Certain temperature variations seemed to align with each other across enormous distances. These alignments had no clear cause. Some researchers quietly wondered if something was fundamentally wrong with their understanding. The cold spot became particularly troubling. This region of the sky appeared significantly cooler than anywhere else in the cosmic background. It was larger than any feature inflation could easily explain. Some scientists suggested it might be evidence of a collision with another universe. Modern satellites have measured the cosmic microwave background with incredible precision. Each new dataset reveals more puzzling details. The patterns are real, but their meaning remains hidden. Inflation explains much, but not everything. The questions multiply faster than the answers. The universe's most ancient light continues to whisper secrets that scientists struggle to understand. The background radiation's smooth appearance masks complexities that challenge everything we thought we knew about cosmic origins. Something created these patterns in the universe's first moments. That something might be stranger than anyone has yet imagined. Modern controversies, data challenges, and conspiracies. The radio waves from space carried secrets that made scientists nervous. Each new satellite brought clearer pictures of the cosmic microwave background. But with clarity came problems no one expected. Dr. Sarah Chen stared at her computer screen in the Madrid observatory. The data looked wrong. Too clean, too perfect. She had spent months checking for errors. But the numbers kept telling the same strange story. Something was hiding in the signal. The cosmic background radiation should show tiny bumps and valleys across the sky. These small changes tell us how the universe began. But when scientists looked closer, they found dust. Lots of dust. Our own galaxy was blocking their view like fog on a window. The Planck satellite had the best eyes ever built for this job. It could see things smaller than a grain of sand from across a football field. Yet even Planck struggled to separate the ancient light from newer interference. Teams across the world started finding problems. The signal they thought came from the Big Bang might be mixed with radio waves from our solar system. Magnetic fields twisted the data. Cosmic rays left false marks. Every discovery raised new questions. Some physicists grew suspicious. Why did the background look so smooth in some places, but not others? The patterns seemed too organized, too planned, as if someone had arranged them on purpose. Online forums buzzed with theories. Amateur astronomers claimed the data had been changed. They pointed to small gaps in the published results. Why were certain regions left blank? What were the space agencies hiding? The controversy spread beyond science labs. Blog posts appeared questioning whether the Big Bang theory was real. Some writers suggested that government agencies were covering up evidence that challenged basic physics. Dr. Chen received angry emails demanding she release raw data. People accused her team of lying about the universe's age. They wanted to know why official reports glossed over measurement problems. The truth was simpler, but more troubling. The cosmic microwave background was real. The Big Bang had happened, but separating that ancient light from everything else in space proved nearly impossible. Each correction revealed new issues. Filter out the dust, and star formation patterns appeared. Remove the stars, and gas clouds emerged. Clean away the gas, and mysterious signals remained that no one could explain. Scientific conferences became battlegrounds. Researchers argued about which corrections were valid. Some claimed their colleagues were seeing patterns that did not exist. Others insisted crucial evidence was being ignored. The public watched these debates with growing confusion. If experts could not agree about basic facts, who could they trust toward truth or deeper mystery? The scientists thought they had it figured out. Each new telescope promised to solve the puzzle once and for all. Instead, every measurement brought stranger results. Dr. Sarah Chen stared at her computer screen in the quiet observatory. The latest data from the Planck satellite showed something impossible. The cosmic background radiation was too perfect, too smooth, like someone had ironed out every wrinkle in the universe's baby picture. But that wasn't the strangest part. Her colleague walked over, coffee in hand. "Still looking at the numbers?" he asked. Sarah nodded. The Hubble tension kept getting worse. Two different ways to measure how fast the universe expands gave two different answers. The gap was growing wider with each study. "It's like the universe is lying to us," Sarah whispered. Teams around the world face the same problem. The cosmic microwave background showed a universe that expanded in all directions at exactly the same speed. Every patch of space, billions of light years apart, had the same temperature. How could distant regions that never touched each other be so perfectly matched? The easy answers weren't working anymore. Inflation theory said the universe grew incredibly fast its first moments. This should explain the smoothness, but new calculations showed problems. The math worked too well. Real universes should have more bumps and irregularities. Some scientists suggested wild ideas. Maybe our universe was one of many. Perhaps we lived inside a simulation. Others wondered if unknown forces shaped space in ways we couldn't imagine. Late at night, Sarah often thought about the first moment after the Big Bang. In that tiny fraction of a second, something created the most uniform signal ever detected. Every attempt to understand it led to more questions. The James Webb Telescope sent back images of galaxies that shouldn't exist. They were too big, too organized for such an early universe. The cosmic background radiation seemed to mock every theory thrown at it. Young researchers joined the search with fresh eyes. They built better instruments and wrote new equations. Each generation hoped to crack the code. Yet the mystery deepened with every discovery. Sarah saved her work and looked out at the stars. Somewhere in that perfect cosmic signal lay secrets about how everything began. The universe kept its earliest memories locked in those ancient light waves. Tomorrow would bring new data, new puzzles. The cosmic microwave background would continue its silent broadcast from the dawn of time, waiting for someone clever enough to read its message. The search continued, driven by curiosity that refused to die.